Hello and welcome to my tutorial on kinetic energy. Today's learning objectives are: can you describe what is meant by kinetic energy? And can you calculate the kinetic energy for a moving object? So today's starter activity: what type of energy do these objects have? That's right, all these objects have kinetic energy. So what is kinetic energy? Well, anything that's moving has energy in its kinetic energy store. Energy is transferred to this store when an object speeds up. Energy is transferred away from this store when an object slows down. Stationary objects have no kinetic energy. And the energy in the kinetic store depends on the object's mass and speed. The greater its mass and the greater its speed, the more kinetic energy it will have in its kinetic energy store. So if you had a question like this in your exam, which moving object has the most energy in its kinetic energy store? The motorcycle, which has a mass of 180 kilograms, travelling at a speed of 30 meters per second, or the car with a mass of 1,500 kilograms, travelling at a speed of 10 meters per second? Right, well, in order to answer that question, you need to know the equation for calculating kinetic energy. So this equation is not given in your GCSE examinations, so make sure you learn it. So kinetic energy is half, or 0.5 if you prefer, times mass times velocity squared. Now, one of the most common errors that I see is that people forget to square velocity. So don't forget to square that velocity. Now, in physics, the different quantities that we measure have a symbol, and their unit also has a symbol. So kinetic energy is written as EK. Now, EK, because E is for energy and K is for kinetic. Obviously, you have half, or 0.5 there. And then you have mass, which is given a lowercase m. And then you have velocity squared. Now, you can use speed or velocity here in this equation. But again, don't forget to square the speed or the velocity. Now, as I previously mentioned, quantities in physics have a quantity symbol, but their units also has a symbol. So kinetic energy is measured in joules, which is a capital J. Mass should be measured in kilograms, kg. And velocity or speed should be measured in meters per second, which is again lowercase m/s. Sometimes you might see that written as ms to the -1. So if we were to go back now and answer that question, which moving object has the most energy in its kinetic energy store? We would need to use the data that we've been provided with. So you can see that the mass of the motorcycle is 180 kilograms. The speed is 30 meters per second. For the car, the mass is 1,500 kilograms and the speed is 10 meters per second. So if we were to calculate the kinetic energy of that motorcycle using the equation, kinetic energy is half times mass times speed squared, you would see that 0.5 times 180 kilograms times 30 meters per second squared would give a total kinetic energy of 81,000 joules. Now for the car, the kinetic energy would be calculated again as 0.5 times 1,500 kilograms times 10 meters per second squared, and that would give a kinetic energy of 75,000 joules. So even though this car has a much greater mass than that motorcycle, with a mass of 1,500 kilograms as opposed to a mass of only 180 kilograms for the motorcycle actually has more kinetic energy. And that's because it's traveling at a much higher speed. And in this equation, you can see because speed is squared, speed is going to have a large impact on that value obtained for kinetic energy. So common conversions that you might need to make in the exam would include turning grams back to kilograms. So to convert grams to kilograms, you would divide by 1,000. Similarly, you might need to convert kilojoules to joules. And to convert kilojoules to joules, you would multiply by 1,000. So what I would like you to do is I would like you to have a go at those 5 questions on your own. And then when you've finished, then green pen mark your answers. Whilst you're completing those questions, pause your video. Don't forget that for some of these questions, you might need to carry out conversions. Right, okay, if you're ready to mark your questions, then obviously continue listening to this video. If you haven't quite finished those questions, press pause. So, question 1, calculate the kinetic energy of a jogger who has a mass of 70 kilograms and is running at a velocity of 8 meters per second. Now, when I attempt questions like this, I always try to dissect the answer. Have a look at what that question is actually asking me for and what that question provides me with. So the question is asking me to calculate the kinetic energy. So the question mark says that's what I'm trying to find out. Now, that question provides me with the mass, which is 70 kilograms, and the velocity of 8 meters per second. So now that I've got that information, I can use it to complete my formula triangle. So 70 kilograms would substitute M, and 8 would substitute V, velocity. But again, don't forget, you have to square the velocity for the kinetic energy equation. So now we know that the equation is, if we cover up kinetic energy, we know that it's half times mass times velocity squared. So the kinetic energy would be half times 70 times 8 squared, which gives a kinetic energy of 2,240 joules. Right, for question 2, it says an MLB player swings a bat which has a mass of 980 grams at a velocity of 36 meters per second. So that baseball player, okay, their bat has got a mass of 980 grams. It's got a velocity when swung of 36 meters per second. But this question is asking you to calculate how many joules of kinetic energy are transferred to the ball. And in addition, it's asking you to provide your answer to 3 significant figures. If you're given an instruction like answer to 3 significant figures or 2 decimal place, etc., always make sure you follow those instructions, because if you don't, you will lose marks. So again, your original formula triangle showed that kinetic energy equals half mv squared. You've got a conversion to make there because you're given mass in grams and you need mass to be in kilograms. To convert mass in grams to kilograms, you divide by 1,000. So 0.98 kilograms is the mass of this bat. So you then substitute these values in your formula triangle. So 0.98 kilograms is a mass, and 36 meters per second is your velocity, so 36 squared. So kinetic energy is half times mass times velocity squared, so that's half times 0.98 times 36 squared, which is 635 joules to 3 significant figures. Right, question 3. A golf pro swings her driver at a velocity of 50 meters per second. She transfers 1,250 joules of energy to the kinetic store of her driver. What is the mass of the driver? Now, in this question, you're provided with the velocity of 50 meters per second. You're also provided with the kinetic energy of 1,250 joules. They're asking you to calculate the mass of the driver. So the equation for kinetic energy will need to be rearranged to make mass the subject of the equation. So if you know that you've got 1,250 joules and that you've got 50 meters per second, which is obviously 50 squared in this equation, then what you would do to rearrange that formula triangle, you would put your finger over m, mass, which leaves you with mass equals kinetic energy divided by half times velocity squared. Which, if we substitute the values into that equation, the kinetic energy is 1,250 divided by half times 50 squared, which gives you a mass of 1 kilogram. Right, question 4. A car has a mass of 1,250 kilograms. It transfers 175,000 joules of energy. Calculate the velocity of the car, but to 1 decimal place. So again, you dissect the question. They've given you mass of 1,250 kilograms. They've given you the kinetic energy of 175,000 joules. This question is asking you to calculate the velocity. So according to your formula triangle, if you are trying to calculate velocity, you would cover up velocity squared, which would give you kinetic energy divided by half times mass. Substitute your values into your formula triangle, and you will find that velocity squared equals 175,000 divided by half times 1,250. So V squared equals 280, but you don't want velocity squared, you want velocity. So you would square root that value of velocity squared. So the square root of 280 is 16.7 meters per second to 1 decimal place. And it's 1 decimal place that you've been asked to provide an answer to. Now the final question, an 800-gram javelin is thrown across a field. 180 joules of energy are transferred to the javelin's kinetic store. What is the velocity of the javelin to 1 decimal place? So again, dissect your question. You've been given a mass of 800 grams. You've been told the kinetic energy is 180 joules. You've been asked to calculate the velocity. And again, to 1 decimal place. So your formula triangle is kinetic energy is half times mass times velocity squared. If you're trying to find out velocity, the first thing that you would need to do is do your conversion. So you've been given 800 grams, you know you should be using kilograms for mass. So 800 divided by 1,000 would give you 0.8 kilograms. So you substitute that data into your formula triangle. So you've got 180 joules of kinetic energy. You've got 0.8 kilograms is your mass of the javelin, and you are trying to work out that velocity that the javelin is moving at. So again, velocity squared would be 180 joules divided by 0.5 times 0.8, which would give you a velocity squared of 450. However, we're not looking for velocity squared, we're looking for just velocity. So you would need to square root your answer there. And the square root of 450 is 21.2 meters per second to 1 decimal place. Right, well, thank you for listening to this tutorial. Any questions, feel free to post them in the comment section. Thank you. Bye-bye.